This recording is about number 12 in the Math 313 practice quiz. It reads, the profit function of a commodity is given by pi of q is equal to negative 8q squared plus 6q plus 15. Part A says to determine the marginal profit function, which is the first derivative of the profit function. Part B says to find the production that will maximize the profit. And part C says to calculate the value of that maximum profit. So let us see where we can go for assistance for such a question. We can go to question number 46 on page 70 in the electronic whiteboard. So that's where we are now. And here you have a similar example. The profit pi function of a commodity is given by pi of q is equal to minus 5q squared plus 7q plus 8. So to determine the marginal profit function, which is d pi over dq, we have to apply differentiation, both the constant rule and the power rule. So we find the first derivative of the profit function. The power rule says you've got to multiply the coefficient by the power and subtract 1 from the power. That's what we do here. 2 times 5, 2 minus 1. 1 times 7, 1 minus 1. And the constant rule says any number that you differentiate goes to 0. And then simplification happened. 2 times minus 5 is minus 10. 2 minus 1 is 1. 1 times 7 is 7. 1 minus 1 is 0. Plus nothing. Any quantity raised to the 0 is equal to 1. So this q to the 0 simplifies to 1. So you have 7 times 1 is 7. So the marginal function is 10q plus 7. So is that what was done for this question? Let us check it out. For part A, right, so here we have the profit function. The marginal function means you have to differentiate the profit function. So 2 times minus 8 will give us negative 16. 2 minus 1 is 2. 1 times 6 is 6. And q to the 0 is 1. And 15 goes to 0. So we have negative 16 because 2 times negative 8 is negative 16q plus 6. So basically, that is what was done for part A. Now, part B now says we have to find the production that will maximize the profit. And it says here, equate your solution for part A to 0. In other words, make it equal to 0, then solve for the value of q. Because at the maximum point of a function, the gradient or derivative is 0, indicating a stationary point where the function neither increases nor decreases. So as you can see here in the diagram, at the maximum point, the gradient is 0. So this is the rationale for equating the gradient function to 0. And here in this example, minus 10q plus 7 is equal to 0. And then you solve for the value of q. You add 10q on both sides. So negative 10q becomes positive on the right side. And then you divide by 10. So q is equal to 7 over 10. So let us see if this is what was done in this example. So for part B, we've got to equate the marginal function to 0. So minus 16q plus 6 is equal to 0. And we are going to solve for value of q. Plus 6 was subtracted on both sides to get a negative 6 on the right side. And then now we divide by 16. 16 divided by negative 6 divided by negative 16. Okay, because we did divide by negative 16. And it simplifies to 3 over 8. So this is correct so far. And for part C now, it says calculate the value of that maximum profit. So what needs to be done now? We need to substitute your solution for part B into the original function for profit. So since we got Q here for our value, the quantity that will maximize the profit, we substitute 7 over 10 into the place of Q. And here it was substituted into the original function to find the value of the profit, which we got there as 10.45. So we've got to do the same here. We have to substitute 3/8 into the original function and to evaluate. So let's see if this evaluation is correct. So we have 16.125. Let's see if we get 16.125. So we have a -8 times, open bracket, 3 divided by 8, close bracket, all raised to the power of 2, plus 6 times, open bracket, 3 divided by 8, close bracket, plus 15. And here we have it, 16.125. So it appears that all the 3 parts, A, B, and C, are correct for this question.